Hello and welcome to Scientist Sleepless. If you're listening to this, you're probably somewhere quiet, maybe tucked under a blanket, phone balanced just right in your palm. Maybe brushing your teeth in soft bathroom light. Maybe pacing a slow loop around your bedroom because your body's tired, but your thoughts haven't quite agreed to sleep yet. That's okay. That's exactly who this is for. No urgency here, no need to follow or focus. We're just going to drift, together, through something gentle, something beautiful, something that lives above us every single night, whether we notice it or not. Tonight we're talking about the Northern Lights, also known as the Aurora Borealis, a phenomenon that feels too magical to be scientific and too scientific to be pure magic, a glowing, flowing dance of light across the polar sky, silent, surreal, and fleeting. People have chased them for years, booked flights, huddled in frozen forests, set up cameras on ice. Some wait their whole lives for one glimpse. Others stumble into it by accident, stepping out to take the trash and looking up at the right moment. And then, there it is, ribbons of green or pink or purple weaving like water across the stars. Why does it appear? Why only in certain places? And what exactly are we seeing? Before we go further, I'd love to ask, where are you listening from right now? And what time is it there? Whether it's a 12:48 a.m. sky in Norway or a warm 10:22 p.m. couch in New Zealand, feel free to drop a comment and share. I read as many as I can, and it's quietly beautiful to see how far this sleepy little science circle stretches. And if you enjoy these slow dives through wonder, feel free to tap the like button or subscribe. It really helps me keep making more for you. Now, let's look at the sky. To understand the Northern Lights, we need to leave Earth for just a moment and visit our closest star, the Sun. Not the soft yellow circle we draw with crayons, but the real Sun. A massive burning ball of plasma 109 times wider than Earth, and so powerful that we orbit it from 93 million miles away. And it's not still. The Sun is alive in a way that feels angry, churning, bubbling, flaring, constantly releasing waves of energy into space. That energy takes many forms, but what we care about tonight is the solar wind, a stream of charged particles, mainly electrons and protons, flung outward in every direction. These particles don't just coast aimlessly, they travel fast, and when the solar wind hits Earth's magnetic field, most of it is deflected, like water curving around a rock in a stream. That protective shield is called the magnetosphere, and it's generated deep inside our planet by molten, spinning metal. It keeps us safe, but not sealed. At the magnetic poles, the very top and bottom of the planet, some of those charged particles slip through the field lines and enter the upper atmosphere. That's where the show begins. Those particles, wild and high energy, slam into molecules of nitrogen and oxygen. And when they do, the molecules get excited, literally. Their electrons jump up to higher energy states, but they can't stay there. The laws of physics don't allow it. So they fall back down, and when they do, they release that extra energy as light. That's the glow you see. Nothing more and nothing less than atoms getting briefly excited and calming down again. But the colors, that's the poetry. When you see the aurora, whether it's a ripple of pale green across the sky or a sudden burst of violet, you're watching atoms collide. Oxygen molecules are usually the ones behind that familiar green, the most common color in auroras. But if conditions are right and the particles penetrate a little deeper or a little higher, oxygen can also glow red, a rare, slow-burning crimson that looks like embers stretching across space. Nitrogen, on the other hand, tends to produce more of the blues and purples. These colors depend not just on the type of atom being hit, but also on how high above Earth the collision happens. The atmosphere is layered after all. Thinner and colder the higher you go, denser and warmer closer to the ground. The altitude affects how those atoms behave and how much light they emit when they calm down again. So when we say northern lights, we're really talking about light paintings created by a brush of charged solar wind sweeping across the sky's invisible canvas and colored by the chemistry of our air. And it moves. That's the part that never shows up in photos, the movement. Auroras don't just glow, they dance, shift, unravel. Sometimes it's slow, like curtains swaying in underwater wind. Other times it's fast. It's fun, éxtase. Like a ripple of fire racing across clouds. It's alive in a way that's hard to describe, like it's breathing. Some people say it feels like the sky is responding to your thoughts. Others say it looks like the earth is exhaling. In truth, it's shaped by a mix of invisible magnetic fields, solar wind angles, and atmospheric currents. But none of that quite captures how it feels to stand beneath it. Your brain forgets to blink. Your heart slows. The sky moves, and you stay very still. And yet, even though it feels like a rare magic, the aurora isn't actually that rare. If you live near the poles, you might see it often. The Earth's magnetic field funnels solar particles toward both the north and south poles, creating two glowing rings called the auroral ovals. These ovals exist all the time, day and night, but we only see them when the sky is dark and clear enough. That's why most people associate the aurora with places like Norway, Iceland, Alaska, or northern Canada. Long nights, clean air, not too much light pollution. But technically, auroras can appear much farther south or north in the southern hemisphere, especially during periods of intense solar activity. These solar storms, bursts of heightened energy from the sun, can supercharge the solar wind and send shock waves of particles toward Earth. When that happens, the auroral ovals expand. A glow that normally hugs the Arctic Circle might suddenly stretch as far south as Scotland or Minnesota or even New York. In 1859, a particularly massive solar storm, known as the Carrington event, caused auroras visible all the way down to the Caribbean. Telegraph wires sparked, magnetic compasses spun, and people who had never seen the aurora before looked up and saw the sky bleeding red. Some thought the world was ending. Others just stared. It's one of the most haunting examples of how something so beautiful can come from something so powerful and so distant. But here's something gentle to hold on to. The particles that create auroras are ancient. The sunlight we feel today took tens of thousands of years to travel from the sun's core to its surface. The solar wind takes just a few days to reach Earth, but its story begins long before that. Deep in the sun's roiling plasma, atoms are fused under intense pressure and heat. That fusion creates energy, some of it as light, some of it as particles. So when you see the northern lights, you're watching the sun's energy, born millions of years ago, finally reaching you. It's not just light, it's history. A soft storm of stories arriving at last. And it's silent. That's what surprises most people. The aurora looks loud. The motion, the brightness, the sheer size of it. It feels like it should make a noise, like the crackle of a fire or the hum of electricity. But in most cases, there's nothing. Just wind and snow and your own breath. That said, some people have reported hearing faint sounds during auroras. Soft crackles like static or quiet pops like distant sparks. Scientists are still studying this. Some think it's psychological. Others believe that under very specific conditions, particles interacting with the Earth's magnetic field could create audible effects, but only very close to the ground. Whether real or imagined, the silence of the aurora makes it feel otherworldly. Like the sky is showing off, but doesn't need applause. And the best part? It's unpredictable. Yes, scientists can estimate aurora activity using tools like the KP index or satellite data. They can measure solar wind velocity and magnetic field strength and issue alerts when conditions are good. But there's still mystery. You can drive 3 hours in the cold, stand under clear skies, and see nothing. Or you can look out your kitchen window and catch a 10-minute display. The aurora doesn't follow our schedules. It appears when it wants, and that's part of what makes it beautiful. It asks you to be patient, to look up, to let go of control. It also reminds us how thin the line is between here and space. The aurora happens in the thermosphere, a region of the atmosphere that begins around 80 kilometers, 50 miles above Earth. That's higher than any weather, higher than clouds, higher than where airplanes fly. It's where satellites orbit. It's almost space. So when you look up and see those glowing ribbons, you're watching something that's happening right at the edge of our world. A place where Earth fades into the cosmos. It's like watching the universe knock gently on our ceiling. And maybe that's why the Northern Lights feel spiritual to so many cultures. Indigenous peoples across the Arctic, from the Sami of northern Scandinavia to the Inuit of Alaska and Canada, have stories about the aurora. Some see them as the spirits of ancestors dancing in the sky. Others say they're messages from beyond, or omens of change. In Finland, they were once thought to be caused by a magical fox running across the snow, sending sparks into the sky with its tail, which is where the word revontule comes from, foxfires. In China, ancient texts describe the aurora as celestial battles. In Japan, there's a belief that conceiving a child under the northern lights brings good fortune. Across time and geography, the aurora has always been more than just a light show. It's a mirror. People look up and see meaning. And maybe we still do. Maybe that's why we take photos and book tours and check aurora alerts at 2 a.m. Even in an age of satellites and science, we're still drawn to the sky. We still feel something when the air glows for no reason. We still want to believe it means something. Because in the end, the aurora is a reminder that even the most violent things, solar flares, plasma storms, electromagnetic chaos, can arrive softly. That beauty can come from collision, that the sky still surprises us, and that somewhere, way up high, the earth is constantly whispering to the sun, and the sun is whispering back in color. So maybe tonight, or tomorrow, or years from now, you'll step outside and see the sky catch fire in silence. And you'll remember this: you are standing at the edge of a planet, inside a shield, beneath an invisible storm, watching the universe express itself in color. No music, no message, just motion, just light, just wonder. Let's slow down for a moment and talk about where it all begins. Not in the sky, but on the sun. Every aurora starts there. Every ripple of green, every silent curtain of purple light begins in a roiling, restless sea of plasma 93 million miles away. The sun may look calm from here, a steady circle of light rising and setting each day, but in truth it's a churning, boiling sphere of charged particles, constantly bubbling with magnetic storms and chaotic loops of energy. On its surface, or more accurately in its outer atmosphere called the corona, powerful magnetic fields twist and snap, creating explosions so vast they make the Earth look like a pebble. These are called solar flares and coronal mass ejections. When they happen, the sun doesn't just shine, it hurls billions of tons of energetic particles into space. It's like a sneeze, but cosmic. A burst of plasma and electromagnetic radiation sent hurtling outward at hundreds of kilometers per second. Most of the time, these storms miss Earth. The solar wind streams harmlessly into the void, drifting past planets and moons and dust. But sometimes, the Earth is in the way. And when that happens, something extraordinary begins. The Earth is not defenseless. In fact, we are wrapped in a kind of invisible armor, a magnetic field that extends far beyond the planet itself, shaping and shielding the space around us. This magnetic field, called the magnetosphere, is generated deep within Earth's molten core, where swirling metal acts like a giant dynamo. It stretches out into space like a teardrop, compressed on the side facing the sun and trailing off into a long tail behind us. This is our first line of defense. When the solar wind arrives, a river of charged particles from the sun, it crashes into this field, and the magnetosphere responds like a living thing. It bends, it shifts, it absorbs. Some particles are deflected, others are trapped, and some, guided by Earth's magnetic lines, are funneled toward the poles, where they spiral down into the upper atmosphere. This is where the aurora is born, not just in the sky, but in that invisible dialogue between solar wind and magnetic field. The sun reaches out, Earth holds its ground. And in that collision, something beautiful happens. The charged particles, moving at incredible speeds, slam into atoms of oxygen and nitrogen high in the thermosphere. The impact knocks electrons out of place, pushing these atoms into an excited state. And when they settle back down, when they relax, they release energy in the form of light. Green, red, blue, violet. The color depends on the type of atom and the altitude of the collision. Oxygen at around 100 kilometers produces the bright green glow we know so well. Higher up, it might release deep red. Nitrogen can give off purples and blues. The result is a soft, silent explosion of light, unfolding across the sky in waves. But the aurora doesn't appear evenly. It clusters around the magnetic poles, not the geographic ones, but the places where Earth's magnetic field dives inward. These form ovals around the Arctic and Antarctic, and those ovals shift and stretch depending on solar activity. On quiet nights, they hug the far north and south, but during solar storms, they widen, and the aurora can appear in places that rarely see it. That's why some people catch it only once in a lifetime, and why others, living under those magnetic ovals, grow up with it as a kind of celestial neighbor. For them, it's not rare. It's part of the weather. Still, no matter how often you see it, the aurora always carries a sense of surprise. It doesn't follow a strict schedule. Forecasts can predict high activity, but even on quiet nights, the sky might suddenly flicker to life. One moment you're standing under stars, and the next, a ripple of green peels across the horizon like a slow-motion wave. Sometimes it pulses, sometimes it snakes upward like a flame. Sometimes it lingers like a soft fog of light, never quite still, never quite solid. It's this movement, this restless organic motion, that gives the aurora its magic. Photos can't capture it. Even videos struggle. It's something you feel more than you see. A flickering presence, a breath of light. And there's something deeply human about that. We are creatures drawn to light. From the glow of fire to the shimmer of screens, from candle flames to starlight, we follow it. And the aurora is a kind of ancient light, not just in age, but in feeling. It reminds us of a time before cities, before satellites, before electric bulbs, a time when the night sky was the ceiling of the world, and every flicker had a story. In those days, people didn't have solar wind models or magnetometers. They had myth. They looked up and made meaning. In Finland, they saw a fox sprinting across the snow, its tail brushing sparks into the sky. In Greenland, the Inuit believed the aurora was the spirits of the dead, playing ball with a walrus skull. In Norse mythology, it was thought to be reflections from the armor of the Valkyries, riding to choose the fallen, And in parts of northern Canada, the Dean people spoke of the aurora as the dancing spirits of ancestors, not a phenomenon, but a welcome. These stories weren't wrong, not in the way science sometimes dismisses myth. They were metaphors, interpretations, ways of understanding something too big, too strange to name. And in many ways they captured what science now confirms, that the aurora is a link, a connection between Earth and Sun, between atmosphere and cosmos, between particle and light, between now and long ago. And if you're lucky enough to see it, really see it, something in you will pause. Even if you know every fact, every detail of solar wind and geomagnetic substorms and electron collisions, the aurora still feels personal. It doesn't just exist out there, above the trees. It finds you. It wraps around your sky. It meets your eyes. And for a moment, it makes you aware of scale, of silence, of the quiet, invisible systems that surround you every day. You can't hear it, you can't touch it, but it changes you anyway. Because the aurora is more than just science. It's poetry in plasma. It's color born from collision. It's the sky remembering the sun. And it's us, small and still, watching something older than language unfold above our heads. So tonight, if your sky is dark and your horizon is clear, step outside. Look up. Maybe the stars will shimmer a little brighter. Maybe you'll catch a hint of movement, a soft glow, a whisper of green. And maybe, just maybe, you'll see the earth respond to the sun in light. And you'll remember, we are not separate from the sky. We are part of it. And sometimes, when the solar wind finds its way to us, the sky answers. But now that we've followed the story from the sun to earth, from charged particles to curtains of light, there's something else worth exploring. Not just what causes the aurora, but why it looks the way it does. Because the aurora isn't a single shape. It shifts, curls, dances. It stretches across hundreds of kilometers, yet flutters like a flame. Sometimes it paints smooth arcs across the sky, glowing gently in pale green. Other times it snaps and crackles, shooting vertical beams that tremble like fingers. There are nights when it pulses in rhythm, as if the sky has a heartbeat, and others when it forms perfect coronas overhead, symmetrical bursts of color radiating outward like the center of a flower. These patterns, as magical as they seem, are not random. They are shaped by magnetic fields, by electric currents, by the invisible dance of energy between the earth and the solar wind. Let's step into that invisible realm for a while and trace how the aurora takes form. Begin with the magnetosphere, the Earth's magnetic shield, vast and invisible, but not static. It doesn't simply block solar wind like a wall, it responds to it. As the stream of particles from the sun reaches Earth, it presses against the magnetosphere's outer layer, called the bow shock, named like the bow of a ship cutting through water. This shock compresses the magnetic field on the sunlit side of Earth and stretches it into a long tail on the night side. And that tail, called the magnetotail, is where something extraordinary happens. The particles trapped here begin to swirl, to charge, to gain energy. Picture it like pulling back the string of a bow. The farther it stretches, the more tension builds. Eventually, that tension snaps. The magnetic field lines in the tail reconnect, a process called magnetic reconnection, and release their stored energy in a sudden burst. That energy launches charged particles down toward the polar regions along the magnetic field lines, where they spiral downward and collide with the upper atmosphere. This is one of the most powerful processes in space physics, and it's what fuels the brightest auroras. The ones that ripple like curtains. The ones that explode across the sky in sheets of light. It's not just sunlight filtered through particles. It's a cosmic chain reaction. Energy from the sun, captured and stored in Earth's magnetic tail, then suddenly released in a cascade of light. And here's something remarkable. That process, that entire flow of energy from the sun to Earth and back out into space, is part of what scientists call space weather. It may sound like science fiction, but it's a real and active field of study. Space weather doesn't just give us auroras, it affects satellites, GPS systems, power grids, and communication signals. During strong solar storms, the same currents that paint the sky can induce electric currents in long metal structures, pipelines, transmission lines, undersea cables. In March of 1989, a powerful solar storm knocked out the entire power grid in Quebec, Canada. Millions of people lost electricity in under 2 minutes, not because of a storm on Earth, but a disturbance in the sky. Auroras that night were seen as far south as Texas and Florida. It was a reminder, these lights are not just decoration. They're a signal, the visible trace of enormous forces at play. And yet, despite the scale of those forces, the aurora remains impossibly delicate. Its light is faint, too faint for the human eye to see in full color unless the sky is truly dark. Most people see it as a soft green or pale white shimmer. Cameras capture more, vibrant purples, deep reds, electric blues, but those colors live at the edge of perception. They aren't painted on the sky like fireworks. They're whispered into it, like ink drifting through water. And the shapes, the dancing arcs and waves, are the result of how those particles spiral and fall, guided by magnetic fields that twist and bend and pulse with energy. You might wonder why the aurora seems to move, why it doesn't just glow, but flicker, ripple, shift. That motion isn't wind, it's electric current, vast rivers of electrons moving through space and interacting with Earth's field. These currents, called auroral electrojets, surge through the atmosphere at high altitudes, sometimes moving faster than a jet plane. They cause the lights to shimmer, to dance, to flow. It's a sky painted by invisible fingers, each movement reflecting a shift in the plasma above. And what about those rare moments when the aurora forms a perfect oval, high overhead? When you lie on your back and see the sky form a glowing ring, pulsing like a celestial eye. That's called an auroral corona, and it happens when particles fall almost directly overhead. From the ground, the field lines curve around you in all directions, and the light appears to burst outward from a single point. It's an illusion of perspective, like looking up from the center of an umbrella, but it feels like the sky is watching you back. In fact, for many people who witness the aurora, there's a sense of presence, not just awe, but intimacy. You feel seen. You feel part of something. You forget for a moment that it's all physics and particles and electromagnetic fields. It feels alive, like the Earth is breathing light. And maybe, in a way, it is, because the aurora is Earth's response to the sun, a glowing reply written in the sky. And still, the science deepens. There are more mysteries, more layers. Recent satellite missions, like NASA's Themis project, have given us clearer views of what causes the sudden surges of auroral brightness, known as substorms. These substorms, which can turn a quiet sky into a swirling tempest of color in seconds, are now thought to be triggered by magnetic reconnection in the distant magnetotail. That means the most dramatic auroras don't just come from above, they begin far behind us, on the night side of the planet, in a region no human has ever seen. We're only now beginning to understand how interconnected everything is, how the sun, the earth, the field, and the sky all form one great circuit. It's humbling, isn't it? To know that what we see as beauty is also energy, that a silent flicker of light in the north is the final step in a journey that began on the sun, traveled across space, battled Earth's shield, and descended as light. It reminds us that we are connected, not just to each other, but to the cosmos itself. that the sun and the earth are always in conversation, and sometimes we are lucky enough to glimpse the dialogue. And that's why people chase the aurora, why they bundle up and drive for hours to frozen lakes, why they set up cameras and wait for the sky to stir, because it's not just a light show, it's a reminder. A moment when the boundary between the earth and the heavens blurs, a moment when the night sky doesn't just watch us, it speaks. So what gives the aurora its color? Why are some displays soft green, while others surprise us with streaks of red, violet, or even a rare electric blue? If the aurora is simply charged particles striking the atmosphere, why do these lights bloom in such a painter's palette? To answer that, we have to journey downward, not from space to ground, but into the very structure of the atmosphere itself and into the tiny atoms that make up the air we breathe. The colors of the aurora aren't chosen at random. They're dictated by chemistry, by altitude, and by the kind of atoms waiting in the sky to meet a solar visitor. Let's begin with the most common hue, pale green. It's the classic aurora color, the one most people associate with the northern lights. That luminous, almost ghostly green comes from oxygen. Specifically, it comes from oxygen atoms that float between 100 and 300 kilometers above Earth's surface. When a high-energy electron from space collides with one of these oxygen atoms, it gives that atom extra energy, like charging up a battery. But atoms don't like to stay excited. After a brief moment, they release that energy as light, and in this case, that light shines as green. It's a precise wavelength, 557.7 nanometers, and it takes nearly a second for the oxygen to glow after the collision. That delay is part of why the aurora sometimes looks smooth, flowing, like it's taking its time, because it is. It's dancing in slow motion, lighting up after the impact. Now, if you go even higher, above 300 kilometers, oxygen can do something else. When struck by very energetic particles, it can emit a red glow. This red aurora is rarer, not because the process is uncommon, but because it's faint and spread thin across the upper atmosphere. It's difficult to see with the naked eye unless the sky is especially dark and the aurora especially active. But when it does appear, crimson veils glowing above the green, it adds a sense of depth to the display. A reminder that these lights aren't drawn on a flat canvas but woven through layers of sky. Then there's nitrogen, another key player in the atmospheric light show. When energetic particles hit nitrogen molecules lower in the atmosphere, closer to 100 kilometers in altitude, something different happens. These collisions can create purples, pinks, and sometimes deep blues. Unlike oxygen, nitrogen tends to produce these shorter wavelength colors when it's in its molecular form, two nitrogen atoms bonded together. And because nitrogen emits light more quickly than oxygen, these colors often appear as sharp edges or fringes at the bottom of an aurora band. That's why you sometimes see green curtains with violet trim or bright pink flames shooting upward from the horizon. It's all about what molecule is waiting to be hit, how high it is, and how much energy the incoming particle is carrying. It's a kind of chemical choreography, a layered ballet of light born from physics and probability. And just like in any performance, the conditions have to be just right. Too little solar energy, and the particles won't penetrate far enough to excite nitrogen. Too few oxygen atoms, and you won't get much green. The atmosphere becomes a canvas, but a very particular one. Its colors are dictated not by brush strokes, but by the invisible math of altitude, particle speed, and atmospheric density. And yet, out of that cold precision comes something astonishingly beautiful. What's even more fascinating is how the light behaves once it's created. Remember, these aren't solid beams, they're photons, tiny packets of light emitted by individual atoms and molecules. and once emitted, those photons begin a journey of their own, traveling downward toward us. On clear nights, the photons reach your eyes directly. But if there are thin clouds or ice crystals in the air, they may scatter and diffuse the light, giving the aurora a soft, dreamlike appearance. In polar regions, snow on the ground can reflect the aurora upward, doubling the display. Cameras, too, play their own role in how we perceive the lights. Most night photography involves long exposures, allowing the camera to collect more light over time. This can reveal colors that human eyes might not pick up in the moment. So while your vision might register soft green and hints of red, your camera could show you a sky ablaze with violet and indigo. It's not deception, it's just a different way of seeing. The aurora is real in both forms, in our eyes and in our lenses. And then, of course, there's the perspective from above. Satellites orbiting Earth, like those in the International Space Station, often capture auroras from space. From their vantage point, the aurora appears as a ring, a glowing oval wrapped around each pole. This is called the auroral oval, and it shifts and changes size depending on solar activity. During geomagnetic storms, the oval expands, pushing the lights further south or north in the southern hemisphere, making them visible in places that normally never see them. That's why people in cities like Chicago, Paris, or Tokyo might suddenly find themselves staring up at a sky tinged with green. It's not magic, it's a magnetic storm reaching further than usual. The aurora, in those moments, becomes a traveler, stretching across borders and time zones, reminding us that Earth's magnetic field, while invisible, is a global force. What's most profound about auroral colors is not just how they happen, but how they make us feel. There's something deeply human about looking up and seeing color in the night. We expect darkness. We accept it. But when the sky surprises us, when it glows without the sun, we can't help but feel small and enchanted. That green glow is not just a chemical signature. It's a signal, a message from the sun, translated by Earth's shield, spoken in the language of color. It says, something passed by here, something collided, interacted, and left behind a trace. And we, by looking up, become part of that trace. Even if we don't understand the science, even if we can't name the atoms, we still feel it. That soft glow stirring something in us. A reminder that beauty is often born of collision, and that silence can still carry energy. The sky doesn't just show us light. It shows us cause and effect, motion and stillness, chaos and harmony. So the next time you see the aurora, or a photo of it, or even just imagine it, remember the journey of those colors. They're not lights turned on, they're stories lit up, and each one begins with a particle, a collision, and a tiny spark in the thin air above your head. Now that we've explored how auroral colors form, we turn our gaze to something even more mysterious, the movement of the lights themselves. Because the northern lights do not simply appear and stand still like stars. They move, they shimmer, they dance. Often they pulse like a slow heartbeat. Sometimes they flow like curtains rippling in an invisible breeze. And every so often, they burst into sudden storms of motion, flickering and spiraling across the sky like a celestial firestorm. This movement, this kinetic beauty, is part of what makes auroras feel so alive, so sentient even. But of course, behind the poetry is physics, and behind the wonder is a chain of very real electromagnetic forces unfolding in Earth's upper atmosphere. To understand why auroras move, we must revisit the Earth's magnetosphere, that enormous invisible field that surrounds our planet like a magnetic cocoon. The magnetosphere doesn't sit still. It's not a hard shell or a rigid bubble. It's flexible, dynamic. It flows and flexes in response to the solar wind, expanding and contracting like a breathing organism. When charged particles from the Sun stream toward Earth, they encounter this field and begin to spiral along the magnetic lines. These lines arc from one pole to another, forming a highway for electrons and ions to travel through. But they don't arrive all at once, nor do they hit the atmosphere in a steady, even stream. Instead, their arrival is often modulated, shaped by pulses, fluctuations, and sudden rearrangements in the magnetic field itself. This phenomenon is known as magnetic reconnection. It happens when magnetic field lines break and snap into new shapes, releasing bursts of stored energy. It's as if the magnetosphere builds tension slowly, storing energy like a stretched rubber band, and then, suddenly, that energy is released in a flurry of motion. These events send surges of charged particles down toward the poles in waves, and when they collide with the upper atmosphere, we see the results as movement, curtains undulating, spirals swirling, ribbons shifting back and forth. It's not the light itself that's moving. It's the point of collision, the place where particles strike oxygen and nitrogen. That is sweeping across the sky. Think of a sparkler being waved in a dark room. The light seems to trail and dance, but the sparks themselves are just brief flashes in different places. The aurora behaves similarly, only on a planetary scale. But there's more. Earth's upper atmosphere, where auroras are born, is not a uniform, calm space. It's a swirling zone of thermospheric winds, electric fields, and ionized gases, and these forces interact constantly. Some parts of the sky are denser, others are hotter, and as solar particles rain down, they encounter resistance in some places and ease in others. These conditions create patterns, wave-like shapes, arcs, folds, that rise and fall, giving the aurora its graceful complexity. One particularly beautiful manifestation of this is the auroral corona. Imagine standing directly beneath the auroral oval, looking straight up. When the conditions are just right, the lights converge into a single, radiant point overhead. Beams of green and violet streak outward in all directions, like spokes from a celestial wheel. It's as if you're standing inside the center of a great dome of light. This effect is caused by perspective, by looking directly up the column of particles as they enter the atmosphere from above. Each beam is vertical, but from your position, they seem to radiate like a cosmic explosion. This corona is rare, fleeting, and profoundly humbling. It feels as though the sky is opening, as though it sees you, and in a way, it does. Because the aurora is not just a sky event, it's an Earth event, a planetary interaction customized to your exact position on the globe. The movement of the lights also follows patterns we now understand better through science. For instance, auroras tend to peak in activity around the equinoxes, the times of year when Earth's tilt aligns the magnetic field more directly with the incoming solar wind. These peaks are known as auroral seasons, and they occur in March and September. During these times, auroral activity can increase significantly, even without solar storms. It's a geometric coincidence, a quirk of Earth's tilt and orbit, but one that favors sky watchers hoping to see a performance. The lights also tend to appear in discrete substorms, lasting from 30 minutes to a few hours. These substorms are like musical phrases, bursts of auroral intensity punctuated by pauses of relative quiet. Scientists have found that the magnetosphere breathes during these cycles, releasing stored energy in spurts rather than in a continuous flow. It's nature's way of balancing pressure, of releasing built-up tension in beautiful, visible waves. And then there's the sound, or rather, the mystery of it. For centuries there have been stories, whispers, really, of auroras making noise. People in the Arctic have claimed to hear faint crackling, soft hissing, even the rustle of something moving overhead. These stories were dismissed for a long time. After all, the aurora occurs dozens or even hundreds of kilometers above the ground. Sound waves can't travel that far. But recent research has suggested a possible explanation. It's not the aurora itself making sound. It's the electrical effects triggered in the atmosphere directly above observers. In rare conditions, bursts of auroral activity may cause localized charge separations near the ground, which then discharge, creating audible, faint sounds. Like static, like breath, like something alive. It's not confirmed science yet, but it's a tantalizing hint that the aurora may be more sensory than we thought, not just visual, but felt and heard in subtle ways. The movement of the aurora, then, is not just motion, it's information. It's a visible trace of a long chain of events, from sun to space to sky. It's a signal that Earth is interacting with something vast, powerful, and ancient. The lights don't just dance because they want to. They dance because they've been moved, pushed and pulled by forces far beyond the clouds. And we, standing beneath them, feel that motion too. Not in our bones, perhaps, but in our sense of scale. In our sense of time. The aurora moves because the universe moves. Because Earth is not separate from the sun, but deeply connected, magnetically, electrically, emotionally. So the next time you see the northern lights flowing overhead, don't just watch. Notice how they move. Notice how they change. Remember that you are not looking at a static display, but at an unfolding story, one that began millions of kilometers away and ends in a flicker above your head. A story told in motion, in light, in silence, and in awe. Let's shift our focus now to the color green, not just because it's the most common hue in the aurora borealis, but because within that glowing green lies a deeper story of chemistry, physics, and patience. When most people picture the northern lights, they imagine soft ribbons of green light waving in the sky, sometimes edged with pink, sometimes crowned with purple or blue. But it's that emerald glow, that earthy, ghostly green that dominates auroral displays. So, why green? The answer, as with so much of this beautiful mystery, begins high above us in the atmosphere, where atoms wait quietly for something extraordinary to arrive. Specifically, we're talking about oxygen atoms, at around 100 to 300 kilometers above the Earth's surface, the upper thermosphere. Atomic oxygen is abundant. This is not the same oxygen you breathe, which is made of two atoms bound together. This is single oxygen, just one atom floating free and ready to interact. When high-energy electrons from the solar wind spiral down Earth's magnetic field lines and crash into the upper atmosphere, they collide with these oxygen atoms. These collisions don't break or destroy the atoms. Instead, they excite them, literally. An excited oxygen atom is one whose electrons have absorbed energy and jumped to a higher orbit like a dancer leaping into the air. But that leap is temporary. Eventually, the excited atom returns to its normal state, and when it does, it releases that stored energy as light. In the case of oxygen, that released light just happens to fall in the green part of the visible spectrum, specifically a wavelength of about 557.7 nanometers. It's a beautiful color, not quite neon, not quite pastel. It glows, but softly. It flickers, but gently. And once you've seen it in the sky, you never quite forget it. But here's what makes it truly fascinating. This green light takes time to appear. When an oxygen atom is excited in this particular way, it holds on to its energy for an unusually long time, sometimes up to a full second, before releasing it. That doesn't sound like much, but in the fast-paced world of atomic interactions, it's an eternity. During that time, the excited atom is vulnerable. It might collide with another molecule, like nitrogen, and lose its energy without emitting any light at all. That's why green auroras only appear at higher altitudes, where the atmosphere is thinner and collisions are less frequent. Down lower, below 100 kilometers, excited oxygen usually doesn't have time to glow before it's quenched. Its light stolen by an impatient world. So the green in the aurora isn't just a color, it's a sign of altitude, a clue that the dance is happening in a rarefied space where atoms can whisper before they're interrupted. Now, while green may be the most visible, it's not alone. There's red, too, and this, interestingly, also comes from oxygen. But not the same kind. Red auroras occur even higher, above 300 kilometers, where oxygen atoms release energy at an even slower rate, this time producing light at a wavelength around 630 nanometers. These red lights are more diffuse, more subtle. They tend to hover above the green bands like a soft halo or distant fire. To the naked eye, they can sometimes appear faint or brownish, especially under less intense displays. But on powerful nights, they blaze crimson, giving the sky a ghostly, almost Martian appearance. And then, of course, there's nitrogen. When high-energy particles strike nitrogen molecules, they can produce colors too. Mostly purples, blues, and pinks. These hues often appear at the lower edges of auroral curtains or during bursts of intense activity. They are the accent colors of the aurora. Fleeting, rare, but dazzling. Their presence depends on the energy of the incoming solar wind and the altitude of the collisions. Purple and violet tend to show up where the action is strongest and where the magnetic field lines plunge steeply toward Earth. When you see a curtain of green edged in pink with hints of blue curling at its base, you are witnessing multiple layers of interaction, different particles, different altitudes, different stories, all unfolding at once. And here's where it becomes something more than science. Because while wavelengths and transitions and collisions can explain what's happening, they don't quite capture how it feels. When you stand beneath a sky lit with auroras, you're not just seeing light, you're seeing history. The green glow you witness tonight might be the result of a solar flare that left the sun days ago, traveled 93 million miles, and spent hours shaping Earth's magnetic field before delivering its final gift, a dance of oxygen atoms above your head. You're watching the sun speak in color and the Earth respond in silence. You're witnessing a conversation between star and planet that you were never meant to hear, and yet, here you are. The colors of the aurora, especially that soft, familiar green, remind us that beauty is often slow. It needs space. It needs patience. An atom holding its glow for a whole second, just so you can see a flicker in the night. A molecule letting go of its energy so softly that it paints the sky with something no artist could replicate. And while scientists have decoded much of this process, the wavelengths, the transitions, the chemical choreography, they still speak of auroras with a kind of reverence. Because knowing how something works doesn't make it less magical. If anything, it makes it more miraculous. Imagine a single atom of oxygen created in the birth of our planet, drifting alone in the high atmosphere, waiting. Then, a particle born in the heart of the sun, forged in nuclear fire, travels across space, spirals into Earth's field, and finds that atom. They meet, they collide, and for just 1 second, one full, glowing green second, they shine. That is the aurora. That is what you're seeing. Not just a light show, but a meeting, a reunion of energy and matter, of star and sky, and in between, you, watching, quiet, wrapped in a coat, feeling small and yet strangely central. The aurora doesn't need you to appear, but it changes everything to be witnessed. That green glow hovering above a frozen lake or silhouetted forest becomes more than color. It becomes memory. And through it, The atmosphere, the magnetosphere, and the stars all seem a little more connected and a little more kind. Now that we've explored the colors of the aurora, their greens and reds and whispered violets, let's shift our gaze sideways for a moment towards something we don't often think about when we look up: the shape of the light. Because auroras aren't just colors painted across the sky. They have form. They ripple, twist, arc, and sometimes explode in sudden bursts of movement. They are kinetic, alive, performing silent dances above us that seem choreographed by something older than language. These motions, these ghostly patterns of motion, are not random. They are deeply connected to Earth's magnetic field, the invisible structure that guides and molds the incoming particles from the sun. So let's slow ourselves once again, breathe deep, and follow a trail from light to motion, from color to curve, and uncover why the northern lights dance the way they do. Imagine for a moment that Earth is wrapped in a giant bubble, not a perfect sphere, but more like a teardrop, with a long tail stretching away from the sun. This bubble is the magnetosphere, and it's shaped by the constant pressure of the solar wind. The sun sends out a stream of charged particles in all directions, and when these particles encounter Earth's magnetic field, they press against it, compressing the front and pulling the back into a long magnetic tail. Earth's magnetic field is like a great invisible net, stretched tight around the planet, catching solar particles and guiding them along specific paths. These paths aren't straight, they spiral. The particles follow curved magnetic field lines that arc down toward the poles. And it's at these magnetic poles, not the geographic ones, that the auroras most often appear. That's why the aurora borealis favors places like northern Canada, Scandinavia, and Alaska. Their skies are near the northern magnetic pole, where the field lines funnel the most particles into the atmosphere. The same happens in the south, with the aurora australis near Antarctica. As the particles rush along these curved lines and enter the upper atmosphere, they don't come in a gentle drizzle. They arrive in sheets, in curtains. These are the tall vertical bands you often see in aurora photographs, ribbons of color hanging from the sky like glowing fabric. These curtains can stretch hundreds of kilometers across and reach heights of over 300 kilometers. But their beauty lies in their motion. Watch closely and you'll see them shimmer. Not flicker like stars, but shimmer like reflections on water. That shimmer is caused by variations in the incoming particle flow. Sometimes it's dense, sometimes it's sparse, sometimes it pulses, creating waves that ripple along the auroral curtain, and sometimes, just sometimes, the entire sky erupts. These eruptions are called auroral substorms, and they happen when energy stored in Earth's magnetic tail is suddenly released. Like a rubber band stretched too far, the magnetotail snaps back, flinging particles earthward with intense force. The result is a sudden brightening, an expansion of the aurora across the sky, and a flickering that feels almost electric. You can stand beneath it and feel like the sky is breathing, inhaling and exhaling waves of light. Sometimes the aurora forms arcs, long glowing bridges that stretch from horizon to horizon. Other times it creates coronas, where all the lines of light seem to converge above your head like a celestial spotlight. These are the most intense displays, where the magnetic geometry aligns perfectly with your position on Earth. You look up, and it feels as if the universe is opening. And then there are the folds, sheets of aurora that ripple and curl, bending in on themselves like soft green origami. These shapes are created by turbulence in the upper atmosphere, by waves of charged particles flowing through waves of air. It's a complex ballet, one choreographed not by intention but by physics, and yet it feels deeply intentional, as if the planet is trying to speak, as if the atmosphere is remembering how to dance. But what's perhaps most poetic is how all of this, the ribbons, the pulses, the sudden outbursts, are invisible until the particles arrive. The magnetosphere is there all the time, holding its shape, arching its lines around the globe. The particles from the sun are always streaming, and yet, unless they meet in just the right way, and unless someone is watching in just the right place, there's no show. The aurora is the visible tip of a very large, very invisible process. Like wind made visible only when it rustles leaves, like breath seen only in the cold, and that's why the shapes matter. They are our only clue to the forces at play. The curtains tell us about particle flow. The arcs show us the shape of the magnetic field. The pulses reveal energy stored and released in real time. It's a kind of atmospheric storytelling, written in light, read by those willing to stay up late and look north. Of course, scientists study these patterns with far more precision. They use satellites to measure the strength of the solar wind. They map the magnetosphere in 3 dimensions. They model how substorms unfold and predict where the aurora will appear. But even they will admit, some things can't be fully explained. Sometimes the aurora refuses to follow expectations. It blooms when it shouldn't. It fades when the data says it should shine. It's an old reminder whispered through the sky that nature still keeps a few secrets. And that's where you come in. Because to witness the aurora is not just to see beauty, it's to participate in a global cosmic system. You're not separate from this story. You're standing on a planet shielded by a magnetic field, bathed in particles from a star, watching the atmosphere respond. You're not just watching the aurora. You are inside the system that creates it. You are, in a very quiet, very real way, part of the dance. So the next time you see one of those auroral photos online, or better yet, stand beneath one yourself, take a moment to notice the shape, trace the curves, follow the lines. Let your eyes drift from the base of the curtain to its rippling edge. Imagine the magnetic field lines guiding each strand. Imagine the sun, 93 million miles away, sending particles across space to draw that shape in the air above you. And if you feel a little small, that's okay. You're supposed to. But if you also feel strangely included, like you belong to this rhythm, this structure, this glowing sky, that's okay too, because you do. Now let's shift our attention, gently, to a question that hovers around this phenomenon like frost on a quiet window pane. Why do some people see the aurora easily, while others can't see it at all? If it's truly happening above our heads, above our planet, why does it sometimes feel like a secret show, visible only to a chosen few? The answer, like everything else in nature, is wrapped in layers of distance, of timing, of light, and of perspective. To see the aurora, it's not enough for it to exist. It must be revealed, and the conditions must be just right. So let's step quietly into that space, the space between light and visibility, and uncover why the northern lights sometimes hide, even when they're dancing overhead. The first and most obvious factor is light itself. Not the light of the aurora, but the light from below. Cities, street lamps, billboards, headlights, porch lights. In our quest to illuminate everything around us, we've built halos of brightness around nearly every human settlement. From space, Earth at night glows, not with aurora, but with artificial light. And this glow, this light pollution, competes with the delicate tones of the aurora. You see, auroras are bright, but not in the way headlights are bright. Not like phone screens or fireworks. Their glow is soft, diffuse, and spread across great distances. In dark skies, it stands out like a ghost made of silk. But in a city, that same ghost becomes invisible, washed out, muted, like a candle in daylight. So the first rule of aurora watching is simple. Seek darkness. Real darkness. Go far from the cities. Find a place where the stars themselves feel sharp, where the Milky Way seems like a trail of ash dusted across the heavens. Only then does the aurora reveal itself, like a secret drawn in invisible ink, waiting for the right kind of night. But even in darkness, timing is everything. Auroras are not constant. They ebb and flow with solar activity. After all, the lights are a response, a reaction to particles from the sun. And the sun, for all its brightness, is not always equally active. It has cycles, rhythms, patterns of storm and stillness. Every 11 years or so, the sun reaches a solar maximum, a peak in its magnetic activity. During these times, it throws more solar storms our way, increasing the chances of auroras. The current solar cycle, cycle 25, is slowly building toward its peak. As it does, the frequency and strength of auroras increases. But between these peaks, during solar minimum, the auroras are fewer, fainter, and often confined to the farthest north. So those chasing the northern lights must also chase the sun's moods. There are apps and space weather forecasts that track these changes. Scientists measure something called the KP index, a scale that tells us how likely it is that auroras will be visible at certain latitudes. A KP of 1 or 2? Quiet. Faint. Maybe visible only in the Arctic. A KP of 5 or higher? The lights may stretch far south, brushing the skies over Scotland, Michigan, or northern Japan. A rare KP of 7 or 8, and the aurora might dip down as far as Colorado, or Germany, or Korea. But these moments are brief, unpredictable, and fleeting, like a heartbeat that flutters unexpectedly. And here we meet another factor: clouds. A thick layer of cloud can erase even the brightest aurora from view. The show is still happening up there somewhere above the clouds, but for you on the ground, the curtain never lifts. That's why those who live in the north, in places like Tromsø, Yellowknife, or Fairbanks, often combine their aurora watching with weather tracking. It's not just about activity, it's about clear skies, and patience, and persistence, and perhaps a bit of luck. There's also the matter of your own eyes. Believe it or not, many people have seen the aurora and not realized it. Unlike cameras, which can gather light over time, your eyes rely on more immediate input. In low light, we shift from using cone cells, which see color, to rod cells, which see better in darkness but detect mostly shades of gray. That's why, to the naked eye, the aurora often appears pale, whitish green, or grayish pink. Only when the aurora is very strong do the reds and purples become clear. This has led many a viewer to mistake the lights for clouds or moonlit mist, unaware they were standing beneath one of the most beautiful sights on Earth. So if you're ever out on a dark night and you see something in the sky that looks like a faint moving cloud, wait. Give your eyes time to adjust. Take a photo with your phone. Sometimes the camera will reveal what your vision cannot, the hidden hues of a dancing sky. And then there is the final factor, perhaps the most important one: stillness. Stillness of mind, office of attention, of heart. The aurora does not perform on a schedule. It doesn't announce itself with a drum roll or step into a spotlight. It begins in silence, often faint, often low on the horizon. You must be still enough to see it, patient enough to let it bloom. Some people wait hours in the cold. Some drive north again and again, chasing KP indexes and cloud breaks. Some miss it by minutes, arriving just after the final flicker has faded. And some, by chance or grace, look up at just the right moment and find themselves breathless. But no matter how it arrives, the aurora always gives you the same thing: a reminder that even in a world full of noise, there are places where silence still reigns. That even when we fill our lives with light, there are things that glow better in the dark. That even when the universe is busy hurling particles across space, it still finds time to dance softly across the edge of our sky. So when you ask why the aurora isn't always visible, the answer is not absence, but balance. A balance between sun and earth, between day and night, between awareness and distraction. It's not that the sky is withholding beauty, it's that beauty sometimes requires you to meet it halfway. To listen, to wait, to look up, not for a result, but for a mystery. And when it comes, when that first faint ribbon begins to stir and shimmer, you'll know. Not because someone told you, not because an app predicted it, but because something inside you will quiet, and you'll feel it, that hush, that wonder, that moment when the world seems to stand still, and all you can do is look, because that's what the aurora does best. It turns the sky into a mirror, not one that shows your face, but one that shows your awe. That draws it out of you, like breath, like starlight, like a sigh. And if you're there, truly there, that light becomes yours. But maybe the most magical thing about the northern lights isn't just that they exist, or that they glow, or that they move. Maybe it's that they remind us, in a way few natural wonders can, that we are not alone. Not in the spiritual sense, though that's possible too, but in the cosmic sense. In the shared, undeniable truth that this planet of ours is not floating through space unnoticed or untouched. We are not immune to the sun's storms. We are not separate from the forces beyond our skies. We are constantly, continuously in contact with the cosmos, and auroras are the proof. They are the visible evidence that Earth is in dialogue with the solar wind, that we are brushing up against the invisible fabric of space every moment of every day. Most of the time, this connection is quiet, calm, background hum. But when it flares, when the sun speaks with fire and force, we see it, literally, in color, in motion, in that silent, slow choreography of light in the sky. It's like watching a conversation in another language, one made of plasma and magnetism and glow. And we don't have to understand every word to feel what it means. To be reminded that the Earth is not merely spinning, it is participating. And so are we. And that thought, soft as it is, changes things, because it reframes us. It takes us out of our routines and repositions us in the larger map of things. You are not just a person walking under the sky. You are a person walking through an electric conversation between a star and a planet. You are, at that moment, in a celestial corridor. The aurora becomes more than a sight. It becomes a setting, a place in which your body exists and your mind opens and your heart listens. And maybe that's why people travel across oceans just for a chance to see it. Maybe that's why they stand in frozen fields at 3 a.m., numb in their fingers but wide-eyed in their souls. Because the northern lights are not just beautiful, they're participatory. They pull you into their world quietly. They don't shout. They don't demand. They whisper. And in that whisper, something opens, something vulnerable, something ancient. You become not just a viewer, but a witness. Not just someone who saw, but someone who felt seen. And that's rare. That's rare in a world full of screens and schedules and sound. To be still, to be small, to be surrounded by something larger than yourself that asks for nothing in return, except maybe that you look up, that you notice, that you feel it, even if only for a moment. And in that moment, something settles. It might not be loud, it might not even be clear, but it settles in your chest, behind your eyes, in that quiet inner place that doesn't always have words. It's the place that sighs when you stand at the edge of the ocean, the place that stills when you hear rain against glass, the place that feels without needing to explain. The aurora speaks to that place, and you hear it, whether you know you're listening or not. That's why people cry when they see it. That's why even the most skeptical scientists sometimes fall silent in its presence. Because for all our knowledge, for all our physics and instruments and explanations, we're still creatures of awe. We're still wired to respond to beauty, especially the kind that doesn't need us, but includes us anyway. And that inclusion, that gentle invitation to witness, might be the most healing part of all. In a world that so often feels chaotic, artificial, or transactional, here is a display that is entirely natural, entirely uncommercial, and entirely uninterested in whether you approve. It happens whether you're watching or not. It happens whether you're ready or not. But if you are watching, if you are ready, it welcomes you, silently, radiantly, without condition. It says, "This is what the earth does when it's kissed by a storm. This is what the sky does when it's brushed by a star. This is how the invisible becomes visible, if only briefly, if only for those willing to see." And that perhaps is the final magic of the aurora. Not just that it dances, but that it invites. And in that invitation is something we've always needed, as humans, as dreamers, as thinkers lying awake at night, wondering if we matter. The aurora doesn't answer that question directly, but it gestures. It gestures with light and motion and silence. And we understand, not with our minds, but with our breath, with our stillness, with that part of us that never needed proof, just permission to feel. So the next time you hear the solar wind is active, or the KP index is rising, or someone says, "The lights might be visible tonight," pause. Let your curiosity rise like a tide. Step outside, away from the city, away from the noise. Let your eyes adjust. Let your thoughts slow. And wait, because maybe, just maybe, above you, in that ink-black sky, something ancient is stirring. Something luminous. Something that doesn't care about your deadlines or your doubts or your to-do lists. It only cares that you are there, and that you are looking, and that, for a moment, you remember what it feels like to be part of something so quiet and so vast that it doesn't need to speak to be heard. To truly understand what makes the aurora such a rare, unpredictable companion in our sky, we have to look at something you can't see, not with your eyes, not even with the most sensitive telescopes. We have to look at the magnetosphere, Earth's invisible guardian. You see, our planet isn't just a rock spinning in space. It's a dynamic, living system with molten iron churning deep in its core, generating a magnetic field that extends far beyond the surface. This magnetic field forms a giant bubble around the Earth, stretching tens of thousands of kilometers into space. It's shaped like a teardrop, rounded on the side facing the sun, stretched long like a tail on the dark side. And this bubble, this magnetosphere, is the reason we're not constantly scorched by solar radiation or stripped of our atmosphere like some dry, forgotten moon. It protects us, not perfectly, but powerfully. And it plays a key role in creating the northern lights. When solar wind, that stream of charged particles from the sun, reaches Earth, it doesn't just crash into the atmosphere. First, it encounters this magnetic shield. Most of the time, the magnetosphere deflects those particles. They're swept around the Earth like water around a rock in a river. But sometimes, especially during solar storms, the wind is too strong, or it carries with it a magnetic orientation that clashes with Earth's own. And in those moments, the particles break through, not all at once, not everywhere, but at the poles, at the edges of the field where the magnetic lines curve down into the Earth like invisible ropes. There, the solar particles follow those lines. They spiral in, accelerating along the magnetic field, hurtling toward the atmosphere at astonishing speeds. And when they arrive, when they finally collide with the gases in our upper sky, that's when the aurora begins. Oxygen molecules floating high above the surface absorb that energy and re-emit it as green light. Nitrogen glows blue or purple, At even higher altitudes, rare oxygen reactions emit a faint red. These colors aren't just random, they're chemical signatures, a map of what the solar wind touched and where. It's like watching particles write with light. A message from the sun, translated by Earth's atmosphere, delivered in glowing ink across the canvas of the night. But here's what makes it even more astonishing. This doesn't happen every night. The sun doesn't always send strong solar wind, the magnetosphere doesn't always let particles in, and the atmosphere isn't always still enough or dark enough for the colors to be seen. It takes alignment, it takes cooperation between systems that are usually separated by thousands of miles and countless layers of complexity. And when they align, when space weather and Earth's shield and the molecules in our sky agree to dance, the result is the aurora, a collaboration between stars and planets, between light and magnetism, between chaos and harmony. But it's not just a science story. Not really, because long before we understood any of this, long before we had satellites or equations or particle detectors, people were watching the lights. Ancient humans, Arctic cultures, wanderers and watchers and storytellers. They didn't have a name for magnetosphere. They didn't know about charged particles or oxygen emissions. But they saw the sky shimmer and they gave it meaning. Some believed the lights were the spirits of the dead, dancing in celebration or mourning. Some believed they were omens, messages from gods or ancestors. Others feared them, associating their red glow with blood, war, or misfortune. And while those interpretations vary, they all share one thing: awe. The recognition that this is not ordinary, that it demands attention, that it touches something deep inside the human imagination, the part that sees pattern in mystery and poetry in motion. That part of us hasn't disappeared. Even now, in the age of high-resolution cameras and apps that predict aurora visibility to the minute, we still feel that old awe. We still step outside and gasp, still lift our phones with trembling hands, still forget, for a heartbeat, the names of things, because what we're seeing is beyond names. It's not just beautiful, it's humbling. And maybe, in a world that moves so quickly, that humbling is necessary. Because when you're standing beneath the aurora, all the noise of life falls away. The bills, the inbox, the questions that keep you up at night. They don't disappear, but they feel quieter, distant, like they've been pushed to the edges of your awareness by something older, something bigger, something you don't need to control, only witness. And maybe that's the real power of the lights, not just what they are, but what they do to us. They slow us down, invite us to feel, to wonder, to remember that the sky isn't just a ceiling, it's a living canvas, that the world isn't just digital and concrete, it's electric and breathing and full of light you can't predict, and that you, standing there in the dark, are not separate from it. You're not just a viewer, you're part of the circuitry, your body, your senses, your story. They're all woven into this moment, into this field, into this glow. And that realization doesn't come with words, it comes with breath, with stillness, with the quiet understanding that for all the noise we make, sometimes it's the quiet things that speak the loudest. So, if you're lucky enough to ever stand beneath those dancing veils of light, remember this: you're watching the sun touch the earth. You're seeing the invisible made visible. And somewhere, far above, the magnetosphere is humming. The particles are colliding. The sky is burning in silence. And you, tiny, temporary, and utterly precious, are there to see it. So now, with all that behind us, with particles traced and atmospheres explored, with science unpacked and stardust whispered into story, let's pause and return to something quiet. Let's imagine together the sky, not a sky you've seen in passing, not the one hurriedly glanced at while walking to your car, or the one glowing with city haze above apartment windows. Number this sky is wild, empty, endless. You are somewhere remote, maybe in the cold north, maybe in a clearing surrounded by black spruce, maybe on a snow-covered hill where even your breath sounds loud. And above you, stretching from one horizon to the next, is the aurora. It isn't fast, it doesn't shout. It moves like breath, like silk in slow water. Curtains of green unfold, ribbons twist. There's purple at the edges, faint blue near the base. Somewhere, if you look long enough, a hint of red will flicker through the haze. There is no music, but somehow it feels like music anyway. Every shift, every swirl feels composed, as if the universe had been waiting for just the right moment to lift its veil and show you what light looks like when it dreams. And in this hush, this perfect hush, a thought might rise inside you. Not loud, just there. A small, still truth that doesn't need to be said but cannot be ignored. You are here, you, alive, breathing, watching. A temporary being in a temporary world, standing beneath an ancient sky still echoing with the energy of stars. And somehow, despite the odds, this moment has been given to you. Not explained, not solved, just offered. Like a gift that can't be unwrapped, only witnessed. It's the kind of realization that doesn't need fireworks or fanfare. The kind that feels like both a whisper and a cathedral bell at once. The kind that asks nothing from you, only that you see, only that you be. And in that moment, the northern lights aren't a science lesson anymore. They aren't particles or collisions or excited gases. They're a reminder, a luminous, silent message from the sky that even in a cold universe, wonder burns bright. That beauty exists even when unobserved, and that connection between stars and atoms, between sky and skin, between knowing and not knowing, is what makes life feel full. As your eyes follow the ribbons overhead, you may think of others who've looked up at this same glow. A Sami reindeer herder in the Arctic Circle. A child in northern Canada standing barefoot in the snow, pulled outside by a parent whispering, "Look." A scientist in a sub-zero station blinking through a frost-covered window. Or even someone thousands of years ago with no words for magnetism or sunspots, just a bone-deep certainty that the sky had come alive. And in some strange way, you're all connected now. Through light, through history, through the awe that asks no language. And maybe, just maybe, the reason the aurora speaks to us so deeply isn't just because of how rare it is, but because of how it slows us down, how it reminds us that the sky is not done surprising us, that the universe still holds secrets, that even when we understand the science, even when we can model it, graph it, name each layer of atmosphere by heart, mystery remains. Not the kind we're meant to solve, but the kind we're meant to feel. So here's my gentle wish for you, wherever you are, whether you've seen the lights with your own eyes or only through photos and dreams. I hope you feel that same stillness, that same quiet hum of curiosity, that sense that there is more to this world than what fits inside a schedule or a screen. I hope that sometime, in your own way, you get to look up and feel small. Not in a frightening way, but in the most freeing way possible. Because when you realize how vast the cosmos is, how many forces are quietly at play just to make your sky glow for one night, you also realize something else, that your life, your breath, your story, your presence is part of it all. That the same universe that shaped the northern lights also shaped you. And that maybe, just maybe, that matters. Maybe that's enough. Before we end, if you've found yourself calmed, curious, or quietly awestruck during this journey, I'd love to know. Where in the world are you listening from? And what time is it there? Whether it's 3:12 a.m. in Alaska, or 9:40 p.m. in Iceland, or maybe 6:17 a.m. in Finland, I hope this moment offered you a little peace. And if it did, it would mean the world if you gently tapped the like button. Maybe subscribed for more gentle science stories. That way we can keep exploring together, one quiet, glowing question at a time. Thank you for spending this moment with me, for listening to the sky, and for making room in your mind for wonder. Until next time. This has been The Sleepy Scientist, wishing you pleasant dreams, soft light, and a sky full of answers you don't need to rush to find. Sleep well.